طيب بسم الله الرحمن الرحيم. So we finished last time talking about slot time and maximum cable length, and we said that the slot time is basically the time that the signal takes to go all the way to the end of the maximum length cable and then come back. And we said that this time is the minimum time we need to listen for collision, or we need to watch for collision. And the frame transmission time should be more than this slot time, because if it's less than this transmission time or the slot time, what happens is that the nodes might decide prematurely that the frame has been transmitted successfully because it did not detect any collision during the transmission time. So the transmission time has to be greater than this slot time in order for the node to make sure that the collision did not happen during the entire transmission. So with that said, basically this slot time will be measured in terms of time duration, and because we have different variations of Ethernet speeds, we define the time not in terms of absolute duration, but we define it using bit duration. So we know the bit time for each Ethernet speed, and then we can calculate the slot time based on the speed of the Ethernet. So in general, the slot time is equal to 512 bit times. And again, this number came based on experimental study. Okay, so it's not a magic number. It's an outcome of some experimental studies that have been done to measure the propagation time for the signal to go all the way to the end of the maximum length cable and go all the way back again. So based on this, so we know that, well, first of all, we can calculate the absolute time. If I give you this number, so you know that the slot time is 512 bit times. So based on the speed of the Ethernet, you should be able to calculate the absolute time. So that's easy. The important. Do you have something to say?
Yes, the slot time or the absolute time. What is the difference?
No. This is the bit time. 512 bit times. Okay. So we know that one bit takes, like, for example, 10 nanoseconds or whatever. So the 10 nanoseconds time, this time gives you the absolute time. But I have to give you the Ethernet standard that I'm talking about, whether it's a 10 megabit per second Ethernet or 100 megabit per second or 1 gigabit per second and so on. So basically, the slot time or the bit time is basically 1 over the speed of Ethernet. So the absolute time is 512 divided by the speed of the Ethernet. So having said that, so we know that the minimum frame length should be 512 or more. Right? So the minimum frame length, because this is 512 bits, right? So then the minimum frame length, including everything, including the physical address, the destination physical address, source physical address, and so on, and IP and TCP header and everything, the minimum frame length should be 512 bits. So if we know that the minimum frame length is 512, this means that the destination address, the destination MAC address, which is 48 bits, has to be subtracted from that. If we need to know the minimum amount of data that we can send in a full frame, then we have to subtract all the header length, right? So we need to subtract the destination MAC address, destination source address, the type, and we have the trailer. Okay, so we end up with a data which is a 368 bits, or in other words, about 46 bytes. So 46 bytes is the minimum amount of data that we can send using TCP. Okay, so this does not include the IP and TCP, and we know that IP header is 20 bytes and TCP header is 20 bytes. So if we also subtract this from this data, then we end up with 6 bytes. So we need to send 6 bytes from the application, add to this 20 bytes for TCP, add to this 20 bytes for IP, and add to this 16 bits, and 48 bits for destination MAC address and source address. So if you know that 512 bits is the minimum frame length, I should be able to ask you what is the minimum, for example, IP packet. What is the minimum TCP segment? Okay, and so on. So if I ask you IP packet, this means that we have to subtract the MAC layer header and trailer, and we end up with 46 IP packet. If I ask you what is the TCP segment, then you have to extract the IP header, okay, and include only the TCP header and the data, which is in that case it's about 26 bytes after we subtract the 20 bytes for IP. Okay, so you end up with like 6 bytes from the application, add to this 20 bytes for TCP, add to this 20 bytes for IP, and add to this all the bytes required for header and trailer for the frame, which is it's pretty small frame, but this is the minimum time that we need to spend in order to decide whether there was a collision or not. So typically, of course, as we said before, the frame the data length is about 1500 bytes, I think. This is the maximum. So the minimum now is 46 bytes, and the maximum is about 1500 bytes, and it could be anywhere in between. Okay, that's for Ethernet. Again, this number might be different for any other standards, whether it's wireless or any other wired standards.
So you said for IP address, if you are asking for a packet size, we need to subtract from data what was already there?
Right, so we need to subtract the frame header and trailer,
Yes.
like this,
Yeah.
and the remaining part will be 46 bytes. So this includes the IP header and the data.
Yes.
Okay?
So again, we subtract the IP header.
No, it's the IP packet itself, including the header, including the IP header. Yeah.
Yes.
Okay. You just define what you're talking about. So if it's the IP header and data, then it will be 46 bytes.
Yes.
If you subtract the IP header, then it will be 26 bytes. If you subtract the TCP header, then you end up with 6 bytes only.
For the application.
For the application.
Okay.
So if every header has its own
Has its own length.
Yes.
Okay. And since we're talking about the minimum number of bytes for the minimum frame length, then you just need to define what you are subtracting, and the remaining part, what does it include?
Yes.
If it includes data and IP header, it includes data and TCP header and IP header, whatever. Okay.
You need the bucket not without the header. Out of 46
Right.
on the packet size.
So the 46, you just need to know the 46 includes
Yes.
data plus TCP header plus IP header. This is the important.
Yes.
Okay. So if I ask you what is the TCP segment, including data and the header, then you subtract 20 bytes from here. Okay. If I ask you what is the pure data length, then you subtract the TCP header and the IP header. Okay. Just need to know what does it include what is included within the 46 bytes. It's the TCP header and the IP header plus the data.
Yes.
Okay, this is the important part. Okay, so now there is a very important issue that we kind of skipped while we were discussing the protocols. So we said that if on the LAN, if I want to send to a node for multi-access, for example, I have to send the destination MAC address, right? So normally, if I'm talking about an FTP application or TCP application, I need to know the destination IP address, right? But what if I don't know the MAC address? It's ideally, I know the IP address, right, of a remote host, but I don't necessarily know the physical address,
Yes.
right?
And from the last router, I need to know it.
Right, but it depends whether this remote host is like on the same LAN or in a remote network, right? So if it's on the same LAN, then I need to know the physical address of that host, right? If it's on a different remote LAN or a remote network, then, and I know the IP address of that machine, so I need to ask myself, what is the MAC address that I need to know?
Of the router.
Of the router, bravo Ali. So that's yes. So that's perfectly right. So in other words, the physical address has to be of a host on the same LAN, right? So first of all, how will I know whether the host that I need to communicate with, whether it exists on the same LAN or on a remote LAN? So that's one question that we need to answer now. Okay.
So we need to know they're in the same network.
In the same network, or why? Because if it's on the same network, I need to know the direct MAC address of this host.
Yes.
If it's on a remote network, then I don't need to know the physical address of that particular machine, but I need to know the physical address of the router that exists on the LAN. Okay, so the address that I need is different whether the host that I'm communicating with is on the LAN or on a different LAN.
Yes. So
Right?
we need to know.
So that does not again answer how I would know the physical address of that host.
So like you do you put the address you want with the network address, and then you know if it's on the same network or not.
Okay, so that kind of answers the first part. So if I know my own IP address, and I know the subnet mask because it's part of the configuration of the host, right? And I know the remote address or the host IP address that I'm trying to communicate with. So in order to know whether this host exists on the same network or not, what I need to do is to see whether this host belongs to the same subnet. How would I know that? I have the subnet mask and the IP address. I can end my own IP address. I can end it with the subnet mask to get the network address. I use the same subnet mask with the other host, okay? And I do AND, and I see which subnet does this host belong to. If it's the same, then this host exists on the same LAN. If it's not the same, then it belongs to another network. So if it belongs to another network, then I don't need the physical address of that particular host. I can just look for the physical address of the router.
Doctor, but it might happen that this machine, for example, is trying to communicate with another machine, but they both are in networks that have the same subnet mask.
Cannot be.
Why?
How come? How can this happen?
Subnet mask is not that 255.255.255.
Right?
طيب ما هو ممكن يكون
the subnet mask, but the subnet address
is not the same.
is not the same.
Yes.
The subnet address is not the same. The subnet address is the network part in the IP address, right?
So this is what we have to check. Which is subnet mask? So this is what.
But in order to get this subnetwork address, we need to AND the subnet mask with the IP address. We get the subnetwork address, and we do the same for another host, and we see whether the subnetwork address is the same on both sides, right? So that explains that. So the first part is we have to figure out the physical address that we need, whether it's the physical address of the host or the physical address of the router. Okay, if we are on a different subnets. The second part is, okay, so I know what physical address I need. How do I get it?
Broadcast.
Okay, so I have to use what we call the address resolution protocol. So it's not given by default. I have to possibly look for it. So that's what this part talks about. So the first is to know which MAC address I need. The second is to get that MAC address. So this is the function of a new protocol, which we call it address resolution protocol. So basically, this explains the first part. So if we have this the two addresses, the source address and the destination address, existing on the same network using the multi-access, well, if we use PPP, then we don't need any destination address, right? We can use just all Fs. We don't need the particular destination address. In that case, we don't need address resolution protocol. But here we're talking about Ethernet. Ethernet is used generally for multi-access. So in that case, we do need a physical address of, على فكرة you are creating a lot of distraction. Please. So how does a host know what network it is on? So we know that through the subnetwork address. How do we get the subnetwork address? Is basically we AND the IP address with the subnet mask. We know the subnet address. So if we both exist on the same subnetwork address, then we are on the same LAN. Okay. So we know that I know my own IP address. I know the host IP address for sure because I need to communicate with that host, whether it's an FTP server or a telnet server or whatever. So I know I do have the destination IP. Okay, so what I can do is that I can AND the host address with the subnet mask to get the subnetwork address. In that case, it's 172.16.10.0. And if the destination IP address with the subnet mask leads to the same subnetwork address, then we exist on the same subnet. So in that case, this only gives me the first part, which is we exist on the same address. Then I need to know the MAC address of that particular host. I should be able to get it directly because it's on the same LAN. Okay? طيب. So the second part is how do I get this this physical address? So I know that if we are not on the same network, then I need to get the physical address of the router. How do I get it? In my configuration, I have my IP address and I have the subnet mask and I have the default gateway. So that's what I need. I need the default gateway, right? I do have the IP address of the default gateway, so I can just use the default gateway IP address to get the destination MAC address, right? So how do we get it? We get it through what we call the address resolution protocol. The address resolution protocol is a protocol in the level of IP, similar to many other protocols that we talked about, like ICMP. And ICMP works on top of IP. However, it's in the same layer, more or less. There is the address resolution protocol and RARP. RARP is the reverse address resolution protocol. This is if you know the MAC address for something and you don't know the IP address. This scenario is rarely happening. Usually when I want to communicate with a host, I know the IP address, but I don't know the physical address. The reverse operation is very rare and it does not happen. Okay? So the address resolution protocol maintains a table called ARP table. Similar, so we talked about many tables now, right? There is the switch table, there is the routing table, there is the ARP table. There are so many. There is NAT table, and okay. So the ARP table is very simple. It maps a specific IP to a specific MAC address, right? So when I want to communicate with a specific remote host, so I know my own IP address and I know the destination IP address. So the first thing I need to do is to consult or to look up the ARP table. The ARP table using the destination IP address directly. Again, this IP address might be the address of the host or the address of the default gateway, right?
Yes.
Right? So whether we exist on the same network or not. So if the IP exists in the ARP table, I get the destination MAC address and I put it in the destination IP and that's it. So in that case, I can just use Ethernet and I can use مثلا IP 080. I don't need to do anything specific. I already have the MAC address in the ARP table, so I don't need to do anything. Okay? If there is no match, if I use the destination IP address in the ARP table and I find that there is no match in the ARP table, then I need to do something. Okay? I need to initiate a new ARP protocol request to send it over the LAN. Over the LAN, right? Not over the WAN, right? It's to send it within the LAN only, because I know that whether the host itself or the default gateway, they both exist on the LAN, right? So I don't need to send anything outside the LAN. And it's not practical actually to broadcast something outside the LAN. So if I need to know the physical address of a host or the default gateway on the LAN, then I need to send a message. The message is again similar to what we did for ICMP and all the other protocols. We send it in a broadcast. Yeah, it's like you ask يا جماعة اللي اسمه كذا يرد مثلا. It's like this يعني. So please, if you have this IP address, please respond back. ماشي? So if there is no match again, then we have to do the ARP request, and the ARP request we have Here we have an example that the host IP wanting to send to this destination address. And whether this address is on the same LAN or in a different LAN, we can just get the IP that we want to get the physical address for. So ARP packet look like this. It works directly over, it's on the same layer like IP, and it works directly over Ethernet. There is the Ethernet header will have the destination Ethernet address and the source Ethernet address, and the frame type will be 0x806. Remember, the IP protocol has a type of 0x800, right? So this is the other type that we can use for the ARP protocol. So we discussed only those two types. So we said that in 99% of the time we use IP for the network layer, and in that case this type will be 800. Here it's 806 to indicate that this is not IP, it's ARP, Address Resolution Protocol packet. So in that case, the packet itself is very simple. You just have to specify the operation or the whether it's a request or response, and then we have 4 pieces of information. In that case, we have the source MAC address, the source IP address, the destination MAC address, and the destination IP address. As simple as that. One of these is missing, which is typically the destination MAC address. This is what we are missing. So the sender Ethernet address, we have it. The sender IP address, we have it. The target Ethernet MAC address, this is what we want. This is the one that's missing. And the target IP address, we know that already. So this is the one that's missing. But in order to know this one, here in the Ethernet header, I have to specify a specific destination MAC address. I cannot just use here like question mark. Okay? So this is the Ethernet header. I have to fill this with something. And we said that for the case if I want to know the MAC address of the target, I can just put all F's here to indicate that this is broadcast. Okay? So if you don't know, so generally in the MAC layer, if you don't know the address, the direct address of something, you just broadcast. Similar to what we did for switch, right? We always a broadcast. Because within the LAN, it makes sense. It's a small LAN, okay? So it's localized, and it's okay to send a broadcast. It's not as acceptable for the case of a WAN. It just doesn't make sense to broadcast a packet over the entire, مثلا, internet or a big WAN. It doesn't make sense, right? And usually we don't do that. And that's why the router, if it does not find the destination route, it just does not say, okay, so I will broadcast to everyone. No, it doesn't make sense in that case. You don't broadcast everything on the entire internet every time you cannot find something. So in that case, it's safer to just say discard the packet and stop it. Okay, so basically in that case, we know the destination IP address, so we send an ARP protocol request, and here the request has an op field of 1, okay, and the response has 2. So we put the Ethernet destination MAC address, all F's, to indicate this is broadcast, and this op number to be 1, and then the sender MAC address, we know it, we put it, and the sender IP address, we put it, and here we don't put anything. We leave it blank. And then we put the target IP address. And we send this as broadcast. This means what? This means that all the hosts on the entire LAN will absorb this and will send it to the network layer. They will send it to the network layer. To which protocol in the network layer? To the protocol which has a type of 806. Okay, so this is not an IP protocol. This is another protocol. So in the network layer, there are multiple protocols running, and one of them is ARP. So this will be put on the buffer of the ARP protocol or the ARP service to pick it up. And then the ARP service will pick this up, will read this this entire packet, and then it will figure out that this is a request. All the hosts will do that. All the hosts on the LAN will do that. They will pick up this, they will consume this frame, and they will put it on the ARP service buffer, and then the ARP protocol will pick this up, will figure out that this is a request, and it's coming from a sender which has this MAC address, which has this IP address, and the target IP address that it needs to know the MAC address for is this. Only one will say, yes, I have the IP address. In that case, this one will respond. Will respond is, when it responds back, it responds as as broadcast?
No.
As a unicast, right? Because it knows already the sender IP address and the MAC address. So there is no point of broadcasting the response. Okay, so always the request, if I don't know anything, the request will be in a form of broadcast, but the response is unicast because I already know who sent this request. So the ARP request will have the op field of 1, the ARP reply has 2, and as we said, the reverse address resolution protocol, which is not, is very rarely used, will have the request of 3 and will have the reply of 4. If it's outside the LAN, it's the same exercise, except that the target IP will be the IP of the default gateway.
And then
Same thing.
be on the routers, not on
Same thing. No. We'll send the same request, and only the default gateway, which has this IP, will respond back with the MAC address. So it's the exact same thing, except that the target IP will not be the IP of the destination host. It will be the IP address of the default gateway. If you send an IP address in the address resolution protocol of a host that exists outside the network, then you will not get any response. You will not get any response because there is no match. Okay?
outside the network, not outside the LAN.
Outside the LAN. يعني. Outside the LAN, if you send a target IP outside the LAN, then no one will respond back to you.
So how?
It's like I'm saying in this room, who has the name of Muhammad? Nobody will respond. ماشي.
But we should think about the IP packet. We can't send it outside.
Yeah. If once we know the physical address and we want to send a frame to that particular host which exists outside the network, then we use the IP address of this host and we send the packet directly. But when we send it to who? To the default gateway. The default gateway will then pick it up and will consult the routing table to know how to send it further. And then it will go outside the network and it will have its route until it reaches outside. Okay, but the first step is that I have to know who within the LAN will be responsible to deliver the packet. If the host exists, then it's my responsibility to know what MAC address that I need to send to it directly. If the host does not exist on the LAN, then it's the responsibility of the default gateway. So I need to send it to the default gateway, and the default gateway will send it outside. Is that clear? Clear? Okay. So basically, the ARP reply from this host 172.16.10.25 will have the source address and the source address and the source IP, the source physical address and the source of the source IP of its own, right? Here, the MAC address matches the MAC address here matches the one here. This is the source MAC address, which is my MAC address, right? Right? So this is the source MAC address, and this is my MAC address. The destination address was the source address in the request, right? Because from the request, I get the MAC address of the source, and then I use it as a destination MAC address in the reply. So when someone sends me a packet and I respond to it, the address will be reversed, right? So the destination MAC address here was the source MAC address in the request. So I send back to that destination directly, and since I'm defining a destination MAC address, so this is unicast, so it's not broadcast. So you have the Ethernet header, which includes those three fields. This field will be filled as unicast. This field, I know it because it's my MAC address. The type is the same, it's ARP. Okay, and then I have these 5 fields. The operation code is 2 because it's reply, and then those 2 pieces of information are mine. Okay, so I can just send the source MAC address. This is the one that's missing, right? And the source IP. Okay, that's my IP, and then the destination MAC address or the target MAC address and the target IP address is for the one that sent me this request.
So, doctor, why do you have duplication of information?
Duplication? Where is the duplication?
Why do you have header and then data? And
Right.
we have in the data we have the center's Ethernet MAC address.
It's not duplication. Remember, this is Ethernet header. It has to be there. This is the Ethernet header. You don't say that this is a duplication, so I will not include this. You will not include this. You will never get this part in the network layer, right? So this is the fundamental of encapsulation and decapsulation, right? So here I have to encapsulate the Ethernet header as part of this frame. Otherwise, you will never receive it in the network layer. So first, the data link layer will receive this frame. It will extract this header, and it knows from this header that it needs to send it up in the stack. When it sends it up in the stack, it sends it to this particular protocol in the network layer, right? So this particular protocol will pick it up, and then it will start processing this part here, right? So here, within this part, there's no duplication. Any other questions? Okay, so
the ARP in the network layer, where it's stored?
the ARP in the network layer, the ARP is a protocol. It runs as a service in the network layer. Right? It's a software service that runs within the network layer. Right? Its service, it has a buffer and it runs as an independent process. Okay? Whenever anyone puts anything on this buffer, then I pick it up and I'll start processing it. Right?
It's not on, and I was saying network layer, and in all routers, it's there.
In all routers, in all hosts.
Yes.
A host has all the layers, including MAC layer and network layer and everything, right? It's just that the router, in addition to the network layer, it has a routing table that it has to go to it to look it up and things like that. But that doesn't mean that the host does not have a network layer.
Yes, sure.
All the hosts have network layer, and it has all the protocols in the network layer, including IP, including ARP, including ICMP, including all these protocols.
That's why we have this. So, like for a host, might be connected to different routers which have
Right.
these IP addresses and that MAC address.
Right. So in that case, this particular host will respond back with the missing part. So now I can answer the two questions. I know the physical address of the destination, which I need to deliver this packet to the host, whether it's at the default gateway or directly the host that exists on the same LAN. Okay, so that's